Yeah, good morning in Germany and Europe. Good afternoon in Asia and China. Welcome to our webinar, Sino of the Sino-German Center at Frankfurt School of Finance and Management. As you all know, our topic is DeepSeek and the race to the technological frontier. I'm very happy to be here again with my colleague Rüdiger von Rosen from the Sino-German Center. And of course, I'm also very happy to have three experts about the topic. Professor Shenglin, the Dean of the Zhejiang University's International Business School. We have Dr. Thomas Asikis as a deep learning engineer, as associate technology and a postdoc at University of Zurich. And we have a colleague of Frankfurt School of Finance and Management, Professor Böttcher. He's a professor of computational science here and finance at Frankfurt, computational science at Frankfurt School. Yeah, to the topic, I think that the topic is pretty much clear. We want to learn a little bit and understand. There was already a lot of the press. What is the model of DeepSeek? What makes it different to the American competitors with regards to this large language model? There is some cost effectiveness and also some obviously creativity, different creativity reasoning in the system. We like to discuss this. And of course, the more bigger question is, what does it mean, the emergence of DeepSeek and the AI development in China for the overall race, for the leading technology for the 21st century? Who will be the winner of this race? And there's especially a strong competition between the United States and China. So far, we all assumed the US will make it for the next decades. But again, not only the emergence of DeepSeek brings some doubt about this assumption. And of course, I would hope that our German and European speakers can also say a little bit about the situation in Europe. Of course, we want not be only a watcher of this race, but also hopefully a kind of a participant. The procedure is always the same. In a moment, I will hand over to Rüdiger. He will introduce the speaker. We start with Professor Shenglin and followed by the two others. After their speeches from 10 to introductory speeches, 10 to 15 minutes, we have a Q&A session, so you are most welcome to raise your question, to type in your question. You can also do this during the introductory speak, and we will forward this to the speakers, and we will close sharp at 12 o'clock. So having said that, I hand over to Rüdiger. So Rüdiger, the floor is yours, please.
Thanks, Horst. Professor Ben is one of the most respected and oldest friends of the Sino-German Center for more than a decade, and we know each other even longer. And it's quite important if one sees at the markets these giant losses of the big technical companies in the United States due to certain news. Professor Ben is Dean at Zhejiang University International Business School and Dean Academy of Internet Finance of Zhejiang University. He had many positions with ABN AMRO, Morgan Chase, HSBC, and is founder and director of the International Monetary Institute of Renmin University of China. He has a bachelor degree in engineering and a PhD in economics from Purdue University in the United States. So, Professor Ben, it's yours to explain how the technical progress starts in China.
Thank you, Rüdiger and Horst. Thank you for inviting me. I know the reason I was invited, at least part of the reason, is because the founder of DeepSeek is an alumnus of Zhejiang University. That's my Zhejiang University International Business School. And by the way, the DeepSeek, okay, it's obviously very famous. That's one of the reasons we're talking about this. And the name comes from, to a certain extent, from the motto of Zhejiang University. Zhejiang University motto is seeking the truth and innovating, pursuing innovation. So our famous alumnus, Mr. Liang Wenfeng, he decides that we need to take a deeper seek. So that's the, probably the reason about this DeepSeek. But DeepSeek didn't come as a surprise. It has been about 2 years journey. The first version of the large language model offered by Mr. Liang was in early 2024. Okay, what is so unique or so different from the ChatGPT and others? I guess it's, first of all, is the innovative, algorithm that they use, like some of the so-called mixture of experts models, so that it will create a much more cost-effective, say, approach to that. Okay, and of course the training cost also related to that is much lower, so it's a fraction of that. So based on the, by the way, also it's based on the open source platform. Given all this, the biggest characteristic of the DeepSeek probably is the inclusiveness of the DeepSeek. By inclusiveness, I mean the affordability, accessible to almost everyone, from individual consumers to the smaller businesses who don't have to pay that much at all. Okay, so that makes the technology good for everyone. And I am using DeepSeek as a person. I don't actually have to spend any money for the time being, okay, to use this. So I think that's first of all, that's a good thing, and that's also because of the Chinese ecosystem. People love free stuff, meaning like cost-effective stuff. Okay, and since it's a successful relaunch, the R1 version, the application has been enormous by different industries, not just in banking, financial services, like in terms of fintech areas. Many banks, including like Alibaba's, so-called My Bank, and many other banks are applying that in risk management, in pricing, customer services, but also in healthcare, for example, and including the traditional Chinese medicine, how we can better, measure the effectiveness and how to prescribe that as well, in terms of health check, but also in manufacturing, especially smart manufacturing, what we call, like electric vehicle company like BYD, like the iPhone manufacturer Foxconn. They are all using now DeepSeek to better predict the maintenance of the manufacturing machineries. Okay, so it's a big milestone, obviously, for China, and I think this has got a lot of attention overseas, including the recent Economist article covering Zhejiang University, which is behind the DeepSeek in that sense. How did it come about? Of course, it's not just by accident to a certain extent. I think it has something to do with a number of factors. First and foremost, I think it's the policy environment. Since about the first Trump term, China noticed that there's a lot of so-called sanctions or technological bans of exporting certain technology to China to a certain extent. And China needs to develop what we call technological independence or strategic autonomy in terms of technology. So that has become a national top priority. So scientists, engineers, professors, everybody has been encouraged to do something for that particular policy agenda. And STEM, science, technology, engineering, and mathematics students are getting a lot more attention and support. So, for example, Zhejiang University, which is known as a STEM university, we're getting, more support in terms of like research funding from industry, collaboration opportunities, but also from some of the government research fund. So this too, obviously the policy environment, it is key. That also has something to do with what we call, at one point, what has been considered as a more successful, more advanced success story, like electric vehicles industries, the solar panels industries in China. They have been, the result of years of pursuit, years of effort, okay? And I would consider the recent breakthrough in terms of DeepSeek as an example of the many years of effort as well. So not just DeepSeek right now, many other companies in China, they are doing quite well in AI. They are catching up in terms of Alibaba, in terms of Ant Group, and many other companies. By the way, Alibaba, DeepSeek, they are all from Zhejiang province. They are all from Hangzhou, which is considered as one of the so-called Silicon Valleys in China to a certain extent. And from China's perspective, I'm doing a little bit of survey about the global AI landscape. Okay, if I look at the US, for example, US obviously is still the number one in AI in many other areas as well. They are the number one in terms of basic research. Their computing power is second to none. Their capital, enormous capital capacity to invest. Some of the best talents in AI. They are in Silicon Valley in the United States, including many Chinese who are staying in the United States. Okay, and of course, the high-powered, say chips, which are really, again, China is not there yet. Okay, and of course, the overall ecosystem in Silicon Valley in the United States, and some of the original technological breakthroughs, I think the US is still very much leading. Okay, but China, to a certain extent, and many other countries have something alternative to offer. For example, China compared to the US, our AI side, we are probably pretty good in terms of applications. We are also very strong in terms of data availability because the government is also making the data available. A lot of online e-commerce activities in China, from Alibaba to Tencent. So there's enormous data, which makes the training of the AI agents a lot easier, more affordable. And also, of course, given relatively supportive policy environment, so the applications, the access to data, and the access for some of the trials and so on and so forth, you got basically faster to certain things compared to, for example, in a say medicine side, in a clinical trial. These are things China is probably making it a little bit easier for some of the AI applications. So why Europe? From our observation, Europe is very strong in terms of ethics, in terms of regulation, like OECD's guidelines and so on and so forth. And of course, that can be a double-edged sword. That could slow down some of the innovation. So when I look at the latest AI landscape, that reminds me about fintech. About 15 years ago, 12 years ago, fintech was sweeping across the world. I see 3 different development models for AI, just like the fintech side. The United States model in terms of AI leadership is more driven by their original technology, by their capital, by their computing power, all the top, Microsoft to, to NVIDIA and to all these companies. No other country can compete with the US in that area, okay? So that's more like a technology-led development model. China is more like what we call consumption-driven model or market-driven model. It's driven by the applications. It's driven by data, which is made available through the more, so-called like, applications as well. So China is more like a inclusive AI, inclusive technology. It's like democratizing because of the lower cost model. It's democratizing the AI technology, just like a fintech that was democratizing the financial services for each and everyone else. While Europe, in a way, has the potential to lead the AI and also fintech, just like it did in fintech, in terms of regulations, in terms of how we can better coordinate the global, effort in making sure the fintech as well as the AI is going to be working for the good of the society, for all the people, not just for a few, for all the countries, not just for a few countries. I think in that sense, Europe has a unique role to play. Let me just stop here for the time being. Thank you.
It came to my mind, thank you, Professor Ben, came to my mind that I do hope for you that DeepSeek has reserved some shares for you or the university would be very helpful for the enlargement. Our next speaker is Dr. Thomas Asikis, a professional researcher based in Zurich, holding a PhD from the ETH, the Eidgenössische Technische Hochschule in Zurich, worldwide known. He currently works as a senior deep learning engineer, researcher at Aisot Technologies, a pioneering fintech firm, and he will explain the view, perhaps not from the Matterhorn, but from Switzerland. Please, go ahead.
Hi. Thank you very much for the introduction. I would like to thank Shenglin for the very nice presentation and the viewpoints, and also SGC for the invitation. As mentioned, I'm currently working as senior deep learning engineer and researcher. Recently, I also did postdoctoral studies at the University of Zurich. I'm very technical, so my background is more from STEM, let's say. My alma mater was in finance and computer science, so it was a mix of those two. So today I would like to talk about, give like a very high level or brief introduction on the technical aspects of large language models. So I would like to have some basic understanding on them. And then, given my expertise, I would like to give some, let's say, intuitive observations on how people can use them in finance. And then, because I find the topic very interesting, I would like to offer some technical perspective on the collaborations, on research and deployment between EU, US, and China, and those unique characteristics that Shenglin already talked about, and Lucas will also elaborate more on. So first, what is really a large language model? I assume that we have a lot of technical people in the audience, but maybe we also have some people who are less experienced with the technicalities behind these models. So at their core, they are probabilistic models of language. So we can think of them like they're trying to predict the probabilities of specific words appearing in the next sequence of text. So if I ask a question, the next sequence of text is a sentence, an answer, and we want to find the most likely one, the one that fits that question the best. Now, back when I was doing my master thesis and masters, like a bit more than 10 years ago, if I remember correctly, older language models, we had conditional random fields, LSTMs, they could fit in a very small computer, like the laptop that I'm talking from today. Modern ones can be much larger. So typically training them or even using them for a chat requires machines that cost thousands up to hundreds of thousands or even millions of euros to train and deploy. And why are we willing to pay that very high cost is because these models are relevant to a lot of language tasks. And now with multimodal models, they're also relevant to image tasks, vision tasks, and so on. They can be used to generate text, translate languages, summarize documents. And currently, if you've been up to date last week with agentic AI, we can also use them, like for searching, recommendations. People use them for planning. There are even been studies that showcase them being used for brainstorming and so on. So why are these models so general? Of course, if we speak very mathematically and technically, that would be a whole talk on its own. So we would be spending hours. But speaking based on intuition, I think the first thing that comes into mind in technical experts is the attention mechanism. Broadly speaking, we can say that this is a mechanism inspired by humans. So in an essence, we can say that this is a bio-inspired model. And the core mechanism that describes attention that's being used in transformer neural network architectures, which LLMs use, can be briefly explained as that the model focuses on different parts of the sequence, no matter how far away they are from what we're currently processing. Think of it in a very simplified example that when a person reads a book and the protagonist isn't mentioned for a few paragraphs, we still remember the last state of the protagonist or the story of the protagonist. So when we pick up a reference to the protagonist again, we can link all the past references of the protagonist of the book and somehow make a cohesive story in our mind. And then we can summarize, we can translate that to our friends, and so on. In an essence, the attention mechanism tries to mimic that approach. Researching how we can improve that mechanism, both mathematically and technically, is actually the core that's pushing modern day researchers and applied researchers like me and engineers towards bigger and better models. Okay, so technical improvements on that mechanism is actually, I think, the cutting edge research currently. Furthermore, there have been some other breakthroughs that enable these models. Again, I will not go over all of them because there are a lot. But I think some interesting ones that we see, especially, for example, DeepSeek R1 benefiting from. First is the chain of thought, which is essentially the process that the model shows the reasoning or the linguistic steps that it takes in order to generate an answer in a dialogue. You can think of it as watching a person thinking out loud before they answer a question from another speaker. And if you use DeepSeek R1, especially like if the service that provides it allows it, you can see the chain of thought. So you can literally see the model thinking, correcting itself, like having an inner dialogue, if you would like to say so. Another big improvement that DeepSeek R1 utilized, and it was also mentioned from the previous speaker, it was the mixture of experts approach. Here you can think of it that when we have such a big model, as I said, we need hundreds of thousands of investment to fit those models into memory and use them. Parts of these models, we can consider them as experts. You can think them as sub-modules or sub-neural networks that specialize, let's say, like very broadly speaking, in different parts of the question and the answer. So if the questions that we're asking are more general and they are easy to answer, like everyday trivia, then we use typically what we say shared experts. And then what DeepSeek really improved, it was the interaction between shared experts that answer like more common questions, as I said before, and more niche experts, so experts that specialize a lot in, let's say, more niche questions or parts of the answer. And this big breakthrough is actually one of the breakthroughs that made the model very efficient. So it made it much cheaper to run. So we don't need to spend as much money, as I mentioned before, to train that model and also deploy it and make it accessible to the public. There is also one more extremely impressive technical improvement from the DeepSeek team, and Lucas, I think, will mention it later. But what I want to keep here is that these benchmark mechanisms actually have a lot of room for technological improvements, especially if we want to make them accessible. And I want to point out how much DeepSeek was actually going towards that direction with their line of research in the past years. Now, the next part of my talk is about large language models in finance. And here, as an applied researcher, I just want to make some remarks about practical usage. And the first remark that I want to make is how to use them in finance. So I see people using AI agents and chatbots in their everyday life, for example, to organize a trip. But they also sometimes use them, for example, to predict market movements or trends and so on. So they just directly chat with the agent and ask the agent, okay, where should I invest or how the market is going? The idea is that if a model can reason and communicate well, it should be able to reason about the market. But I want to point out that I don't agree with this approach. LLMs, as I said, are probabilistic models. They want to provide answers, or they're intended to provide answers that make sense when we hear them and synthesize text, but they're not trained to optimize. My main field of application is research and research on reinforcement learning and control. And I want to point out that LLMs are not trained for these kinds of tasks. So please consider not directly using them for financial advisors. But that doesn't mean that they're not useful. They're amazing communication and analysis agents. So actually, this means that we can take some advantage of some recent advances in programming. This is called tooling, for example, the advance that I'm going to speak about. And this is that you can connect LLMs with pre-existing tools that have been coded by human experts that do the financial analysis and predictions, and then the LLMs piece them together in order to give answers to the humans and analyze them further. So this way you take advantage of the LLM being able to communicate in a personalized manner with everyone, and at the same time you make sure that you have like better predictions in terms of quantitative evaluation metrics and so on. The second note that I want to make is that I've seen studies and applied researchers promoting the backtesting of LLMs. There, because we don't have enough historical data in markets to evaluate how good an LLM financial strategy would do after the model was released, people tend to evaluate in the past. I want to advise that if you plan to do this, you really need to train on past available data, the LLM from scratch, and that's an expensive procedure. If you use a currently trained LLM, the risk is that you're using future information to predict the market in the past, and this is going to overestimate the model performance in an optimistic way. So what I want to say here is that if an LLM releases in 2022, do not use the pre-trained model to evaluate it on markets before that period of time. Okay, so this is like a very important key point. Finally, I want to a bit close this talk and give the floor to Lucas and step a bit away from the technical stuff. As it was mentioned from Shenglin, is that EU often seems to have a lot of regulation in place, and because I collaborate with a lot of different students and research partners from EU, I had also from US and China, I've seen the following, that this slow-moving pace, it's good in terms of regulation, but it's also negative. For example, US is more risk-prone. Investors and organizations are more willing to give money for novel research, and this gives birth to new technologies. And China is extremely fast at following this up and improving it. So they tend to pick up the models, they make them open source, accessible, extremely efficient, and they publish the research in a very methodological way. And doing so actually helps research and innovation move at a much faster pace. Europe, on the other hand, seems to have more considerations about sensitive content filtering, proprietary access, personal data misuse, and so on. But sometimes it's too over-focused on that. There are, of course, open source models like from China, we have DeepSeek. From US, we have Meta's Llama. From EU, we have Mistral and a lot of AI research happening in France. But I think we need to have the best from all worlds. So it's nice to have regulation because it helps with, let's say, data privacy and so on and so forth. But it's also nice to have a faster paced research. So my whole conclusion from this is that I believe that we need to trigger more collaborative efforts and try to take advantage of its different way of thinking and research from the different countries. Okay, so I think that's it for me. Thank you very much for listening. And yeah, I would like now to pass.
Hopefully we move in a fruitful discussion. Thank you, Thomas Asikis, for your remarks. And now we are quite happy that we can present our own treasures at Frankfurt School with Professor Dr. Lukas Böttcher, Assistant Professor of Computational Science, and he has close relations to Zurich, as he got his PhD at the ETH Zurich in applied maths and computational physics. It's quite an astonishing career and publication lists in international and national papers on his topics. In 2020, he joined the departments of computational medicine and mathematics and is a research scientist and fellow of the Swiss National Fund. Lukas has worked in the private sector as a computational scientist in the digital solutions group of the Leone Aktiengesellschaft, the leading wire and cable manufacturer. And we are happy that Frankfurt School has really such treasures in presenting these ideas. And we come back, Professor Ben, Wolfgang König is watching you. You must be very aware, our old friend at Goethe University, so we'll have an insight as well. So, Lukas Böttcher, it's yours.
Yeah, thank you. First of all, thanks to the two organizers, Professor Löchel and Professor von Rosen. Really great that you're organizing this event series. And I also thank my previous speakers for these interesting insights that they already provided. So there are two interesting points that I will also pick up in my statement now. So first of all, Shenglin emphasized the necessity of strong engineering skills, and that's right, an important part that should all of us acknowledge, which is also important for our own program developments and the developments of like student skills in general. And another point that both of them mentioned, both Thomas and Shenglin, is European Union AI regulation, which I think is actually an aspect that we should think more about and maybe also get more involved in order to drive technological development and not just regulate things. So the overall question of this event is about what these Chinese advancements in AI mean for technological progress in Europe and also North America. And just to give you a very short answer to this question, it's basically what we see with these developments is basically that they highlight that there's a lot of untapped potential for improving AI models and their efficiency. But this assumes that the regulatory environments foster innovation, right? And that we also have the right funding mechanisms in place. So we cannot assume that we can improve existing models a lot or further develop them if we have too much regulation and if there is not enough financial support for these developments. And one interesting aspect that both Thomas and Shenglin also mentioned is that there's also an increasing openness toward open source AI initiatives. So that's something that we see with DeepSeek very clearly. And it's also interesting if you keep in mind that, for example, models that are produced by OpenAI are not open, right? So DeepSeek is an open source model. OpenAI models are not open source, although the name may suggest that. And to discuss these points in more detail, I will now focus on two key topics. So I will first continue with some comments on the regulatory challenges and the lack of support for innovation and also the lack of support for young talent in Europe. And then I want to comment a bit more on the technical aspects associated with DeepSeek, and also a bit more on the ongoing AI developments. So what are some of the challenges that we face in Europe? And I mean, Shenglin gave a relatively positive remark on that Europe could become a leader in regulatory affairs. And I see it a bit more critical. And I think that there are three main issues. It's not just regulatory issues in the European Union, but we also have a very fragmented market. And there's a lot of venture capital missing to really drive this innovation and support startups. So yeah, overall, we have these three key issues, and these have been also emphasized by the State of European Tech Report. So you can Google that. It's called the State of European Tech Report, and it's a report that provides some interesting statistical figures. So for example, in the United States, the AI investments were about 47 billion US dollars in 2024. In China, it's about 11 billion US dollars. So it's a quarter, right? About a quarter of the US investments. In Canada, UK, and Germany, all below 4 or even below 2 billion US dollars. So one could say that these countries still contribute, but relatively modestly compared to the US and China. If we look at whole Europe, we see that the AI investments in Europe are comparable to the Chinese investments, but still much smaller than the ones in the US. Another interesting statistical figure is the venture capital investments of pension funds in the European Union. Because like one point that we are often asking ourselves is, where should the venture capital come from to support some of the existing AI initiatives in Europe? And we have a lot of good initiatives, right? We have a lot of talented researchers. We have a lot of technical expertise. But if we look at venture capital investments, it's basically just 0.01% of a extremely large figure of more than 9 trillion US dollars from European pension funds that are invested into venture capital, right? 0.01%. I don't have a comparison with these figures from other countries, but I think there's a lot of potential at different fronts to get more venture capital. And just to comment a bit on these European success stories, and there are many, Thomas already mentioned a few. There's Mistral in France. So Paris has a big tech hub that is leading some major AI initiatives. There's a direct connection to the Montreal hub, for example, through Jan LeCun, one of the main figures in modern AI research. We have the Black Forest Labs in Germany that are connected to the developments in stable diffusion. So if you have played around with image generators and some browser applications or some other applications on your iPad, for example, and you type in some prompts and you want to generate beautiful images, this process is based on a method called stable diffusion. And many contributions in this field were actually from the universities in Heidelberg and Munich. And there are many other examples of leading AI methods that were developed in Europe in the past couple of years. Right, so we have many of these examples. What's really an issue is the fragmented market, missing venture capital investments, and also the overregulation, right? And now I also want to comment a bit more on the overregulation and the European AI Act. So some of you may have heard about the AI Act. It became effective in August 2024, so last year, and it introduces quite some regulations on AI models. And I think it's important to also comment on that. Thomas already made the point that many of these models that we are working with today are basically mathematical models, mathematical functions that are composed, and most of these large language models or other neural networks are really just mathematical functions that you still know from high school, but there's so many of them, millions or billions of these functions that are composed, that we need a lot of computing hardware to deal with these functions. But it's essentially just mathematical functions. And so what the European Union decided is that they consider certain AI models, general purpose AI models of high impact. So that's an official term. If the training computation exceeds 10 to the 25 floating point operations or flops. And one floating point operation is, for example, the addition of two numbers, like 1.5 plus 1.5. That's a floating point operation. Now the AI Act, right, specifies that if this number of operations is larger than 10 to the 25, we suddenly have a problem because this is considered as a high impact and potentially dangerous model. Now, right, if you work in this field, you could easily imagine that one can implement certain models that would satisfy these criteria, but right, they may not be like dangerous because you just use them for a specific purpose, or they may not even work that well. But regulating the number of floating point operations or other mathematical operations in a policy document, I think goes a bit too far. It's basically really regulating the underlying mathematics and not the applications that should be potentially regulated. So yeah, that's the first point that I wanted to make. Regulating the mathematics, the linear algebra underlying these models, in my opinion, goes a bit too far because I think what one should focus on are the actual applications and not so much the mathematics. There's another part in the AI Act that is also interesting from an application point of view. So many companies, many institutions want to use or already use AI tools for research purposes or for purposes of improving organizational efficiency, for example. Now, there's another regulation in the AI Act that requires, and the European Union that requires employees to participate in training courses if they want to use AI models. And this basically means that certain companies, certain organizations, other research institutions may not be able to use AI models in their daily jobs if they don't have the right certification. But it's also not clear what the certification should be about. So this is relatively vague in the current AI Act. And there's also an issue that I came across in some discussions with colleagues. So if you want to use certain models in engineering departments, for example, they have to be shielded from the outside world. And Thomas already mentioned that some of these models are trained on historical data. Now, if you want to use them in practice and you should have access to historical data that you can access with your prompts, it may actually not be that useful in practical applications. And so there has to be some more thoughtful discussion involving different disciplines on how to efficiently regulate this whole AI ecosystem. Now let's switch a bit to the more technical parts that I wanted to talk about. So one interesting aspect, and I think that's, I just looked up the ranks again 1 or 2 hours ago. So one interesting aspect about DeepSeek and other AI models is that they're now evaluated in so-called leaderboards. So if you're familiar with AI developments in the past decade or so, you may remember that image classifiers, for example, were evaluated on their ability to classify images into the right categories. For large language models, the story is a bit different because they can do so many tasks. So we don't just want to evaluate them on a single task, but we want to evaluate them basically in a kind of chess player competition. So we take 2 AI models, let them compete on a certain task, and the task can be decided by a user who adds a certain prompt. And then the user decides which one of these models outperformed the other one. So it's like a chess player competition. And this leads to the so-called AI leaderboards. And if we look at the current leaderboards, DeepSeek is really leading some of these leaderboards, even in comparison to the most advanced US models. For example, mathematics tasks, I just looked at the current leaderboard earlier today. DeepSeek is on par with the most advanced ChatGPT model 4.5. So there's no big difference. And in some tasks, it's even a better. Okay, so that's an interesting aspect about these technological comparisons. And one key aspect is also about DeepSeek, and Thomas already commented on that. There have been many technical improvements associated with DeepSeek. And another interesting improvement has been that there is a 57 times or factor of 57 efficiency boost. So the Chinese engineers were able to reduce the memory requirements of these large language models by a factor of 57, which makes them much cheaper to train. And this probably has also to do with the import restrictions on AI hardware that have been imposed by the United States on China. And so these restrictions probably also contributed to more innovation. Overall, I would say that DeepSeek has a lot of positive implications for AI development worldwide, Europe and the US, of course. And this is because that it contributes a lot to the open source development. So all these source codes are openly available. Thomas mentioned these detailed technical reports that have been released with the development of DeepSeek. Again, OpenAI, for example, didn't do that, although the name suggests that they develop open artificial intelligence. This is not the case. DeepSeek does. And also other proprietary models, for example, the ones developed by Google, are not open source too. Another great example in this open source development is PyTorch, which has been developed by Meta a couple of years ago. So PyTorch is the main software that is being used to work with modern artificial intelligence models. And this one has been developed by Meta and then included into the Linux project and released as open source software. And this also benefited the whole AI community. And I think with DeepSeek, it's kind of a similar story. Contributing open source code to the community will really benefit AI developments worldwide. So to conclude, I think Europe possesses the talent and some funding opportunities, but there are many issues with respect to the fragmented market, overregulation, and investment challenges. And what's nice about these DeepSeek developments is that we see that there are still efficiency improvements possible and that open collaboration can accelerate AI progress and development. And I think for Europe, it's important we want to remain competitive and we have the right talent. We also have good universities, good students, right? European policymakers, in my opinion, should shift their focus from restrictive regulations toward fostering AI innovation and also supporting open source developments. Thank you.